My name is Simon. I'm a data scientist here at Algorithma. Recently, OpenAI released their O1 preview model, which they claim have increased capabilities within problem solving, like coding and math. This may have some serious implications going forward in how we use these models. So today, I'll give it a small mathematical problem, and we'll see how it solves it, if it manages to solve it, and what takeaways we can get from that. All right, let's start off by setting up a problem that we'll give to the model. So the problem we're going to give it is, let's say we have a circle that has a radius r. Now within this circle, we'll set up an equilateral triangle. And from the center, we'll eject a line that is as long as the diameter of the circle. Now from the tip of this line, this point, and the three corners here, we'll set up a tetrahedron, or a triangle pyramid, if you will. And the question then is, what is the volume of this pyramid? We know that it's 1/3 times the area and height, which we know to be equal to r cubed square root of 3/2. Now, the interesting thing is going to be to see how the model handles this problem. This is a geometric problem, and the model itself is a language model. All right, so I've sent the description of this problem now to the O1 preview, and I got back an answer, and let's look at it together and see what it came up with. So out of the bat, it seems to be able to translate the sort of description into coordinates, which is really cool. I think that's quite impressive. I haven't seen that capability from earlier models, though it may very well have been there in various forms. It translates this into vectors to define the tetrahedron. Interesting note here, it seems to make a mistake translating this part into a 2, where I think it should be 4. Then it computes the scalar triple product, which to my knowledge you use to calculate volumes in linear algebra. And it gets a volume right here, which is not correct. It does say there's a miscalculation, but in our earlier calculation, the problem solving process, we got this, which as far as I know, we didn't. I couldn't see it do that. But it does revert its answer to the correct one. Now, if that is because it actually figured out that there was a mistake, or it's seen this problem or a similar one before, it's hard to tell, really. But it's quite impressive that it actually gets the correct answer here. And this is a quick explanation. I tried this with the O1 Mini, and it got the same answer, the correct one, which, again, impressive. And 4.0 got sort of close, but not really. So, and that's actually what I expected. All right, so what can we take away from this test? Well, first of all, I think an interesting point is it took a linear algebra approach instead of a geometric approach, which I think most humans would do. Without knowing exactly how the model would train, I would think it comes from the fact that it's a language model and would get all or most of its understanding of the world from text only. The linear algebra approach is more algorithmic in nature. It's stepwise and has a pretty clear way of solving the problem, while the geometric approach is more around abstract thinking and creative thinking, and also comes more naturally if you have an intricate understanding of space and shapes like humans do. So we may see better performance in those types of problems, or problems that can be solved in that manner. However, the other interesting thing is that it got the answer right. Now, it did correct itself, and it's difficult to know if it just got the answer from a problem that it was trained on previously, or if it actually understood that it made a mistake. It's difficult to know, and we would have to do more rigorous testing to know exactly how well it performs here. But it did get the answer correct, and it did it on the first try. Now, it's not a super complex problem, but it still goes to show that we're making a lot of progress in this space, creating models that can do problem solving, and that has major implications for the future and using these models in these types of problems. So we will definitely have to watch this space going forward.